Hello, everybody. My name is Anais Möller, and today I'm going to present you about Fink, which is a broker that we're developing here together with a lot of other people. So let me share my screen. So let's start the presentation. So Fink, the idea is to enable time domain astronomy, of course, and it's a broker designed for LSTT. So we are a joint collaboration. We just started a year and a half ago, and we have been designing Fink especially for LSST and LSST volumes. Now, our technology and infrastructure lead is Julian Peloton, and Emily Ishida and we are the science and machine learning leads. However, this is a community effort, and we have over 30 endorsers of our letter of intent and people from very diverse backgrounds working on science models. So the idea is to have a community-led effort where different science groups can construct models for Fink, and we can enable things like multi-messenger astronomy, microlensing, supernova cosmology, of course. So because it has been recently developed, we are using really recent R&D technology and working in the cloud. And we also want to add values that are going beyond traditional brokers using adaptive learning techniques, for example. So to give you an idea of Fink, here is a design in a nutshell. You can see that it's based on the cloud with technologies like Apache Spark. And the alert stream will come here in the arrow from the left. I'm going to take you over different parts of Fink design. Now, let's start first with the storage. So the idea in Fink is that we will store all raw alerts that we ingest, but also all process alerts. So why do we do this? Because first we want to be able to reproduce results at any stage of the broker during the 10 years of LSST, but we want also to be able to do post-processing and to actually track down selection functions during the whole duration of the survey. Now, in added value, in the processing part, we can have ingestion that I'm not going to talk about, but we can talk about added value. So usually what we do is cross-matching with catalogs. And the idea is that Fink wants to provide classification with partial information within minutes of the alerts being emitted. And of course, here comes all the part of technologies, deep learning, adaptive learning, in order to get classification scores that are improved during the survey, and also suggest possible targets to obtain labels from spectroscopy in order to improve our training sets. So we have designed Fink to improve science scores over the length of the survey, but we also have a very thorough control of versions, so we can reproduce selection functions and know where the state of the broker is. Of course, if you want to evaluate performance, we are able to ingest a simulated stream, of course, with the broker as it was at any stage of its development. Now, Fink has two modules for communication. The first one is communication with surveys and follow-up facilities. And the idea is that, for example, for adding value, we are able to ingest continuously updated catalogs if you have a new label or a new detection of something. Of course, this is very important, especially if you want to get multi-messenger and multi-wavelength cross matches that we can eat like VOE events to enable this real-time science. Now, the other part of communications is through the science portal and API clients. So the idea is that teams can customize their filtering selection using the added values that are world public. And this filtering, you can do it within minutes because we will have the reduce and enrich stream within minutes. Of course, if you want to construct a hierarchical broker, we are able to forward substreams of LSST. And of course, we are building right now a web interface in order that people can play a little bit with the broker added values and outputs, but we will also support API clients. So aside from these added values, one specificity of Fink is that we want to host it in CCI de Pétrole, which is a satellite processing center of LSST data, which means we have a copy of the data there. So the idea is that if you have access to LSST data, we can actually provide you that cross-match with the alert stream from the data that is proprietary to the alert stream, which is a public fine. Now, what's the status of Fink? We are currently deployed in the cloud using a subset of science models, and we're testing it with CTF. And the current science models come from like cross-matching to catalogs, to supernova classification, microlensing, and also searching for GRBs, afterglows. But of course, these are community-driven efforts, so we want to hear from you from other science cases. Now, of course, we still don't have an interface. We're working on that, and we want to improve our science model. But we're already processing the CTF alert stream and the LSST alert sample. And we have been quite good in the technology requirements. So, of course, the design paper is still in progress. The active learning model is being tested. And I'm going to leave you with my summary slide, which gives you an idea where in Fink we are, with green things that are already deployed and being improved, and orange things that we are working on. So thank you very much. And I hope you have questions.